Hello student, this is Dr. CJ Tank and today we will discuss about the appearance, identification, thermodynamic cause and emulsifying agent in the chapter named emulsion. So first of all, appearance. It is a opaque or milky appearance, that is of emulsion. The emulsion, it looks like a transparent due to the smaller globule size and also due to the same refractive index of external and internal phase. Milky white emulsion, it has two type of shade. One of that is the grayish cast and another one is a bluish. Grayish cast, it indicates larger globule size, and bluish cast, it indicates smaller globule size. As identification, here we want to check whether whatever the emulsion we have, it is oil in water or water in oil. So for that, some of the identification tests are there. First one, that is a dye solubility test. Here amaranth and methylene blue, generally it gives blue color in water because they are water soluble. So if we have oil in water emulsion and we are adding into emulsion amaranth and methylene blue, then if it gives blue color, then we can understand that it is oil in water emulsion. Like that, Sudhan-3 and scarlet red, they are oil soluble, that's why it gives red color to water in oil emulsion. If it does not give red color to our emulsion, then we can understand, we can say it is a oil in water emulsion. The next one is a dilution test. Generally in emulsion we have two phases, disperse phase and dispersion medium. So in dispersion medium, if in emulsion, if we add dispersion medium, then if there is no phase separation, accordingly we can say whether it is a oil in water or water in oil. For example, in oil in water emulsion, if we add water and if it gives no phase separation, then it is confirmatory test that the given emulsion, that is oil in water. And likewise, opposite dispersion medium, if we add into the oil in water, for example, instead of water, if we add oil, then it will show phase separation. So on the basis of dilution test, again we can understand whether our emulsion is oil in water or water in oil. Then conductivity test. Generally water has ability to conduct the electricity. On the basis of this, we can understand whether our emulsion is oil in water or water in oil. If water as a continuous phase, water as a continuous phase, generally in oil in water emulsion, water is as continuous phase, then this conductivity test gives positive result. If oil is a continuous phase, then it gives negative result. So on the basis of this, we can understand we have oil in water emulsion or water in oil emulsion. The next one is a creaming test. The direction of creaming. Generally oil have higher density compared to water. So that's why in water in oil emulsion, it gives the downward creaming, whereas in oil in water emulsion, the creaming, it will be upward. So on the basis of direction of creaming, we can understand whether we have water in oil emulsion or oil in water emulsion. So these are some of the identification tests for the emulsion. Then thermodynamic cause for instability of emulsion. See, emulsion that is thermodynamically unstable. So here we are going to discuss why it is unstable. See, in emulsion, cohesive force of like molecule is greater than the adhesive force of unlike molecule. In emulsion there are two phases, oily phase and aqueous phase. So always oil particle, they have tendency to come together. So always there are higher chances of phase separation when two opposite direction phase it comes together. For example, oil and water. So any system like any emulsion if we prepare, so always it will try to remain in a stable condition. In stable condition always it have low surface free energy. If we increase the globule size, so if we increase the particle size or globule size, if we decrease the particle size, and in this condition interfacial area will be higher, that means surface area will be increases. In such a condition, interfacial free energy it will be raised, but the stability will be decreases. Here one of the equation has been given for the surface free energy. For example, delta G is equals to gamma O by W into delta A. Delta A, that is the surface area, surface area of globule, and gamma O by W, that is the interfacial tension between oil and water. Now here, if we take delta A, change in the surface area, if we want to decrease the surface area, if we are decreasing the surface area, then surface free energy will be decreases and it will give the stable condition to our emulsion. But over here we can system cannot changes to original, so delta A, it cannot be 0. Surface area we cannot decrease totally, so like that the delta A, it would never become 0. So delta G also, it cannot become 0. If it becomes 0, then there will be the separation of phases, and whatever the emulsion we prepared, it will come into the unstable condition. So for that, the regrouping of globule that can be prevented by emulsifying agent. Here we can add emulsifying agent which can avoid or which can prevent the regrouping, and by that we can have the stable emulsion. The another thing, that is gamma O by W, that is the interfacial tension between oil and water. We can reduce this interfacial tension, but we cannot go up to 0. And to decrease the interfacial tension, we need to add surface active agent into this. See, we can see the same thing by figure also we can understand. For example, we have one of the mixture, oil. In that oil and water, both the things are present. This mixture that is in a stable state, when we were converting them into the emulsion, we are mixing them, we are going for a size reduction process. Then afterwards, one phase it will come, that is water in oil, another one it will oil in water phase, but the system it will goes in unstable mode. That means surface area that is going to be increases. Here the globule size, surface area, it will be large, it will be increases, and due to that surface free energy that will be also increases, but the system comes as a unstable mode. Now if you want to convert them in a stable state, so for that we can add water soluble emulsifying agent or oil soluble emulsifying agent. Accordingly, if we add water soluble emulsifying agent, then we can have oil in water emulsion. Likewise, if we add oil soluble emulsifying agent, then we can have water in oil emulsion. So now again, if there is a changes in the stability mode, if these small globules, they will come closer, and then afterwards they will fuse together, and afterwards there will be 4 globules will be converted into two globules, it will be converted in one. If this process will occur again, then again it will come to the stable state. So vice versa also we can say, always the emulsion, it want to achieve stable state. So that's why we say is that emulsion that is thermodynamically unstable. Always they have tendency that oil and aqueous phase always they want to separate from each other. So that's why the phenomena it comes that emulsion that is thermodynamically unstable. For that we need to add emulsifying agent. So also we should have knowledge about the emulsifying agent. It stabilizes the emulsion by preventing collisions of dispersed globules. It forms bridge between the polar and non-polar phase. Some of the examples are there: span, acacia, soap, twins, gelatin. These all are emulsifying agent. According to Benton's rule, if the surfactant is more soluble in water than the aqueous phase, it will become continuous phase or external phase. So it will give oil in water emulsion. For example, some of the example: twin, acacia, bentonite. These are more soluble in water, so that's why it will give oil in water emulsion. Spine, it has solubility in oil, that's why it will give water in oil emulsion. Some combination also we need to use, some oil soluble and water soluble, both two type of different emulsifying agent. We can make them together, one combination, and we can use as a emulsifying agent to make stable emulsion. Then some auxiliary emulsifying agent, they can act as a thickening agent and help to stabilize the emulsion. Thickening agent, that means they will increase the viscosity of emulsion and by that make it in a stable condition. The examples are glyceryl monostearate, stearic acid, sodium CMC, sodium carboxymethyl cellulose, then methyl cellulose, stearyl alcohol. These are the example of auxiliary emulsifying agent. Another emulsifier with a high HLB that means hydrophilic lipophilic balance, which are preferentially soluble in water and produce oil in water emulsion. For example, Twin 80, which has HLB of 15, sodium oleate, which has the HLB of 18. Then emulsifier with low HLB value favors the formation of water in oil emulsion. For example, SPAN, which has 4.3 HLB value, then glyceryl monostearate, which has HLB of 3.8. Then combination of oil soluble and water soluble. For example, if we take Twin 20, then it has 16.7 HLB value. Then SPAN 20, it has 8.6. So we can take the combination of these two, which has the HLB value of 12.65. Then ionic type of emulsifying agent, SLS, triethanolamine stearate, they are not recommended for internal use because they can interact with the biomembranes and adversely affect the cell function. So that's why we should restrict the ionic type of emulsifying agent if we are preparing the emulsion for internal use. Then better to avoid emulsifying agent with natural origin. Some natural origin emulsifying agent are also available in the market. So we should avoid such a natural origin because it shows batch to batch variation, and also there is a chances of microbial growth in our emulsion. So meanwhile the selection of emulsifying agent, we need to take care of this thing. So this lecture, it includes the appearance identification, then thermodynamic cause for the unstable of emulsion, and about emulsifying agent. Thank you.